We're looking at question 21, October 2020 paper. In this question, a student adds a solution of bromine to an organic solvent to 2 test tubes. Or in an organic solvent to 2 test tubes. The student adds aqueous sodium chloride to 1 test tube and aqueous sodium iodide to the other test tube. The student shakes the mixtures and allows them to settle. And records the color of the organic layer in each mixture. So, let's draw this out. Tubes. You've got the organic layer that's going to be at the top. Initially, you started off with bromine, Br2 plus NaCl, Br2 plus NaI. And upon shaking it, the second test tube gave you a purple solution, and the first one, the organic layer, was orange. Explain how the student's results provide evidence for the trend in reactivity of the halogens down group 7, and write an ionic equation for any reaction that takes place. Okay, you see the orange organic layer. You need to learn your colors. Orange organic layer contains bromine. That means no reaction took place. And took place between NaCl and Br2. For the other one, the violet color of the organic layer contains iodine. You see the halogens, they show up, their colors show up very well in organic layers because they themselves are non-polar, halogens are, and something like cyclohexane is also a non-polar solvent, so they dissolve better and they show their colors better. So the violet color contains iodine. Now you see, so a reaction has taken place. And what is that reaction? Give an ionic equation. So we've got Br2 plus I minus from the sodium iodide. It's gone on to produce iodine and bromide ions. That's your ionic equation. What does this tell us? You see, out of the halogens in group 7, bromine cannot displace chloride. This reaction doesn't happen. But bromine can displace iodide. This tells us that the reactivity decreases down the group. We can use different terms. We can say oxidizing power decreases down the group. We could say it gains electrons less easily. or forms -1 ions less easily. Yep. Or down the group. Yeah, just these are possible answers for this point over here. Now, the explanation, it says here, explain those evidence for the trend in reactivity. Use your chemical knowledge to explain the trend in reactivity. You see, these three factors explain reactivity. You see, nuclear attraction helps explain the trend in reactivity because D is the distance, is the atomic radius, S is shielding, and N is nuclear charge. You see what's going to happen as you go down the group. There is a greater atomic radius and more shielding. And because of this, the nuclear attraction is less. So this increases, and this decreases. Even though the nuclear charge increases, this effect is outweighed. They don't want you to talk about that. So these are your 5 points. 1, 2, 3, 4, 5. Chlorine is used in water treatment. State 1 benefit. Now, the tremendous benefit of adding chlorine to drinking water is that it kills bacteria. Yep, kills bacteria. Great benefit. Otherwise, we'll be getting infections all the time. What's the downside is that actually chlorine is toxic. It's poisonous. And, it can also go on to form chlorinated hydrocarbons, which themselves are carcinogenic. So this is a bit off topic, but you know what? Invest in a Brita jug or some other decent water treatment system. And you're looking around about sort of 5 pence per litre of top quality water, probably better than the water bottles you buy from the shop. Get a Brita filter. Moving on. Compound A contains bromine and fluorine only and has a boiling point of 41 degrees. 1.26 grams of compound A is heated to 80 degrees Celsius. The volume of gas produced is this much. Under the conditions used, 1 mole of gas has a volume of this. Determine the molecular formula of compound A. So, if we do volume divided by, volume 0.209 dm cubed, and divide that by the new or greater volume per mole of gas. (0.0072068965) moles, and we've got the mass of compound A. We now have the moles of compound A. This will give us the MR. 1.26 divided by that answer. This gives us 174.8. And you see, bromine, Br, is 79.9. Bromine is 79 0.9, and fluorine is 19.0. Yep. So now we need to find a combination of these two elements to fit 174. Now, we could use two bromines. So 79.9 plus 79.9, that gives 159. So that gives you 159.8. That's two bromines. But that leaves only one fluorine to add on to that, plus 19. That gives you 178, which is above that amount. So let's cross this out. Not two bromines, let's just do one bromine. Let's do Br. So 174.8 minus 79.9. 174.8 minus 79.9 gives you 94.9. 94.9, let's divide that by 19. And that gives you pretty much 5. So that will be BrF5. Yep. 1 mark for the moles, 1 mark for the molar mass, and 1 mark for the answer. That is the end of this question. See you tomorrow.